gentlemen. So today we're going to be taking a look at square roots. And a square root is the inverse of squaring. So when I'm looking at a number, if I had, for example, if I know that 3 squared is 9, well, the inverse of that is saying that the square root of 9 is 3. This right here is called the square root symbol. It's also called a radical sign. They mean the same type of thing. So the radical sign, it looks like this, and we read it as square root. Right? So the square root of 9, and this is because these are opposites of each other. So you need to know how that works. A perfect square is a number whose square root is a whole number or terminating decimal. I'm sorry, I ran out of room. Terminating decimal. Right? Terminating means that it ends or stops. All right? You need to have memorized the first 15 perfect squares. Okay, you need to have those memorized. So we're going to go through and make this list, and we've been dealing with some of these right away anyway. But 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36. I'm going to stop talking and just fill those in. Most of you know up to 100, which is great. And then we have 121, 144, 169, 196, 225. So the numbers that I wrote in, this is an example of a perfect square. Because in order to get 4, I had to multiply 2 times 2. So the square root of 4 would be 2. That's called a perfect square. All right, so let's see if we can do these. Now, we deal with what are called positive square roots because we know that if I multiply 2 negatives together, I could also get a positive answer. So that's why you'll see it written, determine the positive square root if it exists. Meaning, is this a perfect square? So when you see those words, if it exists, it's another way of saying, is it a perfect square? And if it is, find the square root of it. So they're saying what times itself gave me 81. Well, if I look up here, 9 squared gave me 81. So the positive square root of 81 is 9. Why? Because 9 times 9 gave me 81. So that's your reasoning. Determine the positive square root of 225. Well, 225, square root was 15. The reason? Because 15 times 15 was 225. All right. Determine the positive square root of negative 36. Well, if I look up here, none of my numbers are negative. Because whenever I multiply 2 positive numbers together, you have to get a positive number. So I can't. This one does not exist. No positive times a positive gives a negative. Okay, number 4, determine the positive square root of 49 if it exists. So I'm going to go back up to my list. 49 was 7, so square root of 49 is 7. Explain. I'm going to abbreviate because 7 times 7 equals 49. Okay, let's see what we got on the other page. This is hopefully, again, pretty easy. It's just kind of using our square root stuff. So now they want us to place square roots on a number line. Well, if I start taking a look, it says use the number line above. We're going to place the square root of 1, 4, 9, and 16 up here. Well, I already know the square root of 1 is 1. So right here, I can put in the square root of 1 is equal to 1. Those are the same. The square root of 4 is 2. So right here, I can put the square root. Oops, sorry, I did that wrong. I meant to put the Anyway, the square root of 4 is up here. Square root of 9, we know, is 3, so I can put the square root of 9 here. Square root of 16 is 4, so that one would go up there. Okay, so far so good. Well, now I want to put the square root of 2 and 3 on the number line. Well, the square root of 2 and 3 is going to be between the square root of 1 and 4. So, in other words, in between 1 and 2. So, if I take this and divide it up about evenly, so this would be the square root of 2, and this would be the square root of 3. Right? Square root of 1, 2, 3, 4. These are perfect squares. The one in blue are perfect squares. So they fit exactly at a number. 2 and 3 are going to be somewhere in between. So the square root of 2 is between 1 and 2. The square root of 3 is between 1 and 2, but closer to 2. Okay. We can do the same for the radicals up to square root of 16. So in other words, if I wanted to now put in the square root of, oops, I forgot 5. If I want the square root of 5, 6, 7, and 8, those are going to fit in between the square roots of 4 and 9. Right, so here I'm going to kind of put them above and below. So here's the square root of 5, and then the square root of 6, square root of 7, square root of 8. And then we get the square root of 9. And in between the square root of 9 and the square root of 16 would be the square root of 10, 11, 12, 13, 14, and 15. So let's see, 1, 2, 3, 4, 5, 6. Ooh, that got a little tight. So you could see here, so we would have the square root of 10, and then the square root of 11, square root of 12, square root of 13, square root of 14, square root of 15. I just wrote them above and below to try to fit it so that my handwriting could fit. So now we can use this idea of the number line to help us predict, well, if it's not a perfect square, what numbers is it going to be in between? Okay? So hopefully you see how that worked. So first I want to know, determine the positive square root of the given number. If it's not a perfect square, determine which integer the square root is closest to. Okay. So the square root of 49, that's one of my perfect squares, that's 7, because 7 times 7. Now, square root of 62. If you go back to your list over here, square root of 62 is not on my list. But 62 is pretty close to the square root of 64. Right? 62 is pretty close to 64, which means the square root of 62 is close to 8, because the square root of 64 is 8. So I'm using these to help me. It's not going to be exactly 8, but it's going to be pretty close. If I have the square root of 122, again, it's not a perfect square, but this is close to the square root of 121. 122 is close to 121. So this is close to 11. It's going to be a little bit more than 11, and this one would be a little bit less than 8. Okay. And the square root of 400 is 20. That is one that you should hopefully be able to figure out, because I did the square root of 4, and then I just took one of the zeros. Which of the numbers from the previous question were not perfect squares? Well, the ones that were not was the square root of, square root of 62 and the square root of 122. Why? There was no number that multiplied by itself to get 62 or 122. Okay? So here we're talked about in our lesson summary, just saying that our square root symbol, what it looks like. The fact that, for example, the square root of 4 is always 2, not negative 2, so it always is talking about a positive square root. And perfect squares have square roots that are equal to integers. And that there are lots and lots of numbers that are not integers. So any questions, as always, bring them to class.